Yes, yes, man. Hello. How are you doing today? You love all the content? Thank you for that. I'm glad it's helpful. Okay. Oh, Uncle only destroyed one of these. That's cool. I might have an idea of where this TIS 100 machine came from. Zero. So something described the architecture to. I described the architecture to Fred at Motorola, and he says it sounds like it was designed for signal processing. That got my brain going. Government project maybe. Something the CIA cooked up to comb through Soviet radio signals. Hush hush. Top secret. Maybe could I be in possession of a classified device? Something for spooks? I might have to sit on this one for a little while. Oh, you're on the third watch through the U playlist? Oh, nice. Thank you. Hopefully it is helpful. And I know that it's a little bit old and like new things have come out. So I'm glad that you're able to go through it and get a lot of value out of it. Okay, so we have 3 ins and 1 out. Read values from in.a and b. Read a value. Okay, wait. Read values from in.a. Read a value from in.s. Write in.a when in.s is -1. Write in.b when in.s is 1. Write in.a plus in.b when. What's that classic programming interview question? This reminds me of that. FizzBuzz. This is FizzBuzz. You should do a project using U plus Actix Web plus SerialDB. I will add that in to my list. So something like create something with, what is it? U Actix Web and SerialDB. Okay, autocomplete totally butchered everything about that except U. So it's not Actin Web, it's Actix Web, please, and not SerialDB. Thank you. Yeah, I got it added to my list. No guarantees of when I'll be able to get to that though. Flip-flop gate? Yeah. It doesn't look like any game most people would enjoy. Again, it's for programmers. It's a programming game. Also, it's one of those sort of like weird fun, but only if you're like really into programming and doing little challenges with that. Also, hello Blah, how are you doing today? Yes, this is called TIS 100 and you program assembly to play it. Okay, so all right, so basically when s is -1, we write out, so okay, so hold on. Read a value from in.s, write a when in.s is -1. So I might want to do something like move up, right, move up, left. And so just immediately take these two and merge them in here. And now we're gonna have to start using labels for this. So if, okay, write in B when, okay, so if this, so move, probably want to start, move up, ACC. If this is -1, okay, so if this is -1, I want to take U and then move you down. So we're gonna have, basically we want left, we want right. So jump when less than Z. We'll do left. So in your case, I want to move left down. Okay. However, if you're not less than, then if you're when okay, when you are 1, so oh, is there a way for me to see? Okay, you're always 1 or -1. So I can just use this. So okay, if you're J greater than Z, right? So this is going to be right down. However, if I do this, we need to handle the other one. So I just need to drop, I need to catch the when we're on the left here, I need to catch the B1 and just do something with it. Can I? Oh yeah, I could just I can just save it into ACC, which I think drops it. I can like move right. Is there like null? There's no null. Oh, it has to be like a register, so I have to do like that. So move left ACC. Okay, and then when it's equal to 0, oh, there is a 0 register. Let's try. If I do move left to 0, okay, fine. We can look at the documentation. Oh, memory stuff. Oh, nice little stuff for us to deal with. Oh, we could do breakpoints. Oh, that's cool. Wait, I can draw stuff on here? Oh, that's interesting. Also, they're literally showing me the back end of the PDF through this. Here's the note from the ant, I think, because I see the lev ant. Oh, that's cool to sort of like pretend that it's double-sided. That's a nice little a touch there. Oh, advertisements are about to start. Okay, 5 minutes. So we have 5 minutes until break time. Why does this game have so many registers? Is it a puzzle mechanic, or do real systems look like that? I'm pretty sure it's for a puzzle mechanic. I have no idea if real systems look like this. This is also like pretending to be a like a CIA computer that was doing like kind of code breaking or whatever. So that makes sense too. Nil. Okay, nil. That's what you were talking about. So move right to nil. Move left to nil. Okay, and then when it's 0, so if it's neither of those, then I want to jump to 0, or jump to both. For both, right, left plus B. Okay, so move left to ACC. Add right, move ACC down. Ooh, just, that's it. I can't add any more. This is how much I can do. But then it goes back up to the top, which I think is good. So then we just do move up, down, up, down. Okay, let's try it. Uh-oh. That... Okay, so the first one is right that we got. You would have split the control data to both sides rather than combine the sides. Oh, yeah, that could have been a good idea too. As opposed to like just do it all in one. Okay, so the second one, okay, so -1 and 1 works. Now, what happens? I'm out of order on these. That's not a good sign. I move up to ACC. Oh, my left is continuing. I need to jump back up to start. Oh, okay. So, you know, we can't do this because I don't have enough. I literally don't have the room to add the jump command to go back up to starting and restart this. So I think you're right, Albert. We have to split these off. So yeah, we can make the sum later. Yeah, I could make the sum later. Have each side output their data or 0, then make the sum later. Okay, so oh, and then I always sum. So like down here, we just do move left to ACC, add right, move ACC down. So this like adds them together at all times. And then you're going to move up to ACC, and then I want to check to see, okay, so if you are, maybe if you're coming in, if you're 1 coming in here, I want, oh no, it adds it, yeah, you tell me. Okay, so if you're 1, I keep you to be whatever A is, and if you're 0, I reset you to 0 and I move that down. So then we're gonna have to use like start, move up, ACC. This hands it a 1 or a 0. So if oh, ad break started. Okay, we're gonna take a quick break, and then we'll continue on. So let me Vampire, was that break really short for you? Either way, for everybody else who's watching, we have to run these ads on Twitch. Otherwise, we have, well, they run the ads for us just constantly. So anyways, I can do them all at once at the end of the hour, which is what I'm doing. So I'm going to go grab a quick drink, and I will be right back. All right. Are we back? I think we're back. Day loop. Redeeming quack. Oh, we have a bunch of quacks. Hold on, we can do this. Where's my quack? Oh, I don't have. Okay, hold on. Let me add quack in on the browser. This is just Firefox. Firefox quack. That. Oh wait, no, not that kind of browser. I wanted remove. But what did I remove? I removed something and I didn't want to do that. Okay. Oh, I know what I want. I want to do that. Go to you. Place you with that. That is what? Hold on. Now I'm really confused. There we go. Now we have quack. And then I need to figure out, how do I play it? Interact. Can you hear that? Oh, you can't hear that. Okay. I can barely hear it. Let me take a look at Twitch chat. Oh yeah, there's no audio for that. Oh, I don't know how to make it so that way OBS knows to listen to that. Okay, so I have to add in audio out, audio output capture, desktop audio. Okay, hold on. Let's try this. Oh, that's loud. Sorry about that. That's still loud. There we go. How's that, quack? Okay, sounds good. Excellent. How many quacks did we get? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 quacks. That was glorious, the loud one. All right, we'll do 13 quacks now. I know, poor duck. Poor duck. Exactly. But we got 13. I think I got 13 quacks in there. There was some of them that were like double quacking because I thought it was done, but it wasn't done. It would be nice if the audio playback could overlap for rapid fire clacking. That would be really cool. Maybe if Danaka is here, maybe that's something we can add in eventually. Okay, select all, complete. Okay, so, and then you can go away and you can go away. Okay, back to the game. Now, I'm curious. How do you all like the music with this? Like with this specific game, because I think there's only beeps with TIS, so it's not really like anything special here. So let me know. Do you want the music or not? I'm impartial either way. 3-minute break is still on the screen. That is true. Thank you for that. Music is nice. Okay, well, we'll turn that back on. Why aren't you on? Oh, that's loud. Sorry about that. Duck audio and music audio are at different balances. Okay, here we go. We're good to go again. Now it's a bit low. Okay, let me turn it back up. How about that? Excellent. Okay, let's continue on. Okay, so what I probably want to do here is, if this is okay, so we move. I don't want to move up to ACC. I need to move right to ACC. So move right to ACC. And then if this is 1, so if it's greater than 0, then I want to jump to we want right A when it's okay. So then I want to just keep this, right? So we keep. Otherwise, we're going to jump to drop. And then I think that's it, right? Yeah, that's it. So here we have keep. If we're keeping, I want to move up, down, jump to start, and then we have drop. If we're dropping, I just want to move, I want to move 0 down and then move up 0. And then that can go back up to start again. And then I kind of want to do the exact same thing. So can I copy and paste this? Kind of. Okay, so this is going to be move left ACC, and then if it's greater than 0, keep it. Otherwise, drop it. Move up to down. Jump back to start if we're keeping it. Move 0 to down. Move up 0. Okay, and now we reset this. Okay, so move up to ACC if we are okay, so if it's less than 0, I want to run left, which is here. If it's greater than 0, run right. If it's otherwise, run both. So actually, I want to, can I get rid of both and just do like, no, I don't think I can. Then run both. Okay, so move. So all I want to do is, in this case, I want to move 1 left. And I already moved up to ACC, so then I'm good to go. And then we can jump start. If we're right, we want to remove 1 right, jump to start, and if we're both, move 1 left, 1 right. So that way it keeps both of them, and then it goes back up to the top again. We don't keep you at all. And just okay, so if we run you, nope, that's really no. Okay, so I'm jumping to start, jump to start on this one, jump to start on this one. I'm dropping inputs because they are not moving at the same rate. Okay, so we start with 13, -1, 7. -13 and -7 are sitting in their inputs here, and we haven't started moving. So we go into, okay, so less than 0 left. Move 1 left. Oh, I need to move 0 right. That's a problem. So if we're moving left, I also need to move 0 right. And okay, that won't work. Okay, so this is too complex again. I wonder if I should start over and we should do something simpler with this. Like, I move there's no if statements, right? So this is our way of doing if. We move 1 left. I almost want to then want to, okay, so if I move up to ACC, if you're less than 0, move left. I mean, I guess I could just move you over and then it sort of figures out what it's supposed to do. I was kind of hoping that I wouldn't be able to have to do that. Yeah, well, I was really hoping that I can basically like remove 1 to each side, so that way I separate out like the, I guess like that's the sort of like the programming thing. I wanted to normalize it and make it so that they didn't have to care what the logic is of this. They just know that, but you're probably right. We should probably just do something like move up to ACC, move ACC left, move ACC right. And then we'll have to do move right to ACC. So keep that. Equal is not supported. Let's find out. Can I find in here? There is no EQU. Oh, I can't find less than though. Oh, this is just an image. Oh, I can't. Is there no text in here? There's no text, so I can't search it. I'm not seeing an EQ. Finwo, hello. I'm not seeing a compare either. So I don't think I can. That would be nice if I could do that, but I think I can only check zeros. Check the jump statement. Okay, so we have jump. We have just jump to a label. The instruction after the label will be executed next if the value of ACC is 0. So if the value of ACC is not 0, positive greater than 0, negative less than 0, and just transfer it relative position. Yeah, so I don't think there is a compare. It's just greater than or equal to 0. Okay, yeah, so oh, were they good? Night Control Z this. Oh, that goes. Oh, I can't. Oh no. Okay, so hold on. Move ACC left, ACC right. I can't Control Shift Z. I can Control Shift Z, still just undoes. Oh, compare equals subtraction, then JEZ. Compare equals subtraction? Like I want to subtract it, then compare it? Well, I can just say, okay, if you're negative, if you're less than 1, Control plus Y. Oh, you're right. That is that. Okay, so we move right into ACC, and then I want to say, okay, if you're greater than 0, so really want to say if you're less than 0, keep, otherwise drop. Ooh, okay, so I want it J equal to 0, keep also. So move up, down, jump back to start, move 0 down, move up, no, nil. Okay, so that might work. Okay, if you want to compare A to B, you can do A minus B, and then A is greater than B. But I can't compare if A is greater than B, right? I can only compare if it's greater than 0 or not. Because there was no compare statement. Like I can't do compare right. Because invalid opcode compare. Okay, so then if we do the exact same thing, so move, when we start, move left to ACC. If it's greater than 0, we keep it. If it's equal to 0, we keep it. Otherwise, we drop it. Move up to down, jump back to start. Okay. Oh, if you load A, subtract B, then check to see if it's equal, jumps if they're equal. Oh, but I'm not checking to see if these two are equal. I'm checking to see if this one is 0 or not. Because I only want A plus B if S is 0. So this might work better. Yeah, there we go. All right, I got a message from work. I gotta respond to them really quickly, and then we will continue on. Okay. Okay, here we go. Next, more plot. Okay. Oh, this is several years later. The new girlfriend is encouraging me to get rid of the microcomputers I've accumulated over the years. Not a bad idea. Most of them are just taking up space and aren't doing me or her any good. Going to wait on this one though. Never found out what its whole deal was, and if it turns out to be something I wasn't supposed to have, I think I can get in trouble. Cleared a little space on a workbench and hooked it up. Still works. Beautiful. Yes, it is a beauty, this one. Okay. Oh, that's interesting. We only get a few ins and outs. Okay, so sequences are 0 terminated. Read values from in.a and in.b. Write the lesser value to out. Write the greater value to out. Write 0 to end the sequence. Okay, so I want... Here's I think what you're talking about, Finwo, is that we can start... We can check those. I can basically subtract A from B and then see if it's less than 0. If it's less than 0, I guess if they're the same, then it doesn't matter. I just choose one of them and then we go with the other one. And then we do 0. Okay, so if we do... I feel like I want to move both these down, just straight down, and then maybe the core logic happens here? So right, I want to check, or I could just do core logic here and just move this straight over here. Right, the lesser value to out, right, the greater value to out. Okay. Oh, which means I need to keep them. I can't lose it. So I want to... We want to subtract A from B. So let's say I do like move up to ACC. Want to save. So we have a backup. Let's just say I like move up ACC, move ACC left. So now I have access to this one and that one and my previous one. If I sub right, if you are greater than 0, that means B is higher. B is greater. Okay, so write the greater value to out. A is greater? Let's see, if this is negative, so if this is, yeah, okay, 46 here, and then 71. Let's pretend this is just what, 40 and 70. So the difference would be 30. It'd be positive. Oh, it's greater than 0. That means B is bigger. If it's less than 0, A is bigger. No. You're right. Wait. Less than 0, B is bigger. Yes. Okay. Math. Okay, so, and then I just write... Oh, so I need to choose which one to pull at which time. Interesting. And then we write a 0 to end the sequence. I wonder if I actually just want to do the logic here. And then it can pull one from the other. Okay, so if I do that, we subwrite if jump greater than 0. Okay, so greater than 0. So 46 minus 71. That'd be negative, which means so if it's greater than 0, A is right. So A. Otherwise, jump to B. So if you are... okay, so if A, so A is greater, we're going to want to write A out first. So we have to restore. Oh, swap. Move ACC down. Move right down. Jump. Start. Ooh, I don't think that's good. I don't think I have enough. With B, okay, so I probably want to swap once. So JGZ A. Oh, but I need a, oh, I do need a swap. Okay. Just add the operation in the same line as the label. That works fine. Oh, wait, I can? Oh, that's cool. That will give me more time, more space. Like that. Okay, so for you, I want to swap, move right down, move ACC down. No need to jump start, because then we're back up at the top again. Oh, and then we move okay, so we do that, then you down here. It's gonna move up, right, move left, down. Okay, so if I want to move up, down, move up, down, move 0 down. So that way I null terminate after 2. So if I do that, it's unhappy. Oh, with this construction, you'll save node if you put the logic in b.node. node. Yeah, that's true. Because then I could just go straight down. I don't have, yeah, that's very true. However, this is unhappy. So we start here. So we have 46 and 71 coming in. So 46, 71. I save, so we have a backup of that. I want to sub right, so we have negative 25. If you're greater than 0, we want A. But you're not, so we're going to jump to B. Okay, so we're going to swap. So we get 46 here. We're going to move Oh, wait, the first one was 71. I lost it. That's the problem. I'm already at 90 here, and I needed this one to be the same. So we need to say, okay, so I move up to ACC. I move ACC to left. You sub the right. We lost the ACC. I then want to move right down, so I need to move ACC left again. It's not a move, it stays in ACC. Okay, so I think that might be better. Nope. That's okay, so we still have 71 here, which is right. $71. Okay, we go into swap. Move right down, so 71 goes down. Oh, wait. My out is supposed to be 46 out. My logic is backwards. Great. Okay, so hold on. My logic is backwards, which means that this is supposed to be B, this is supposed to be A? Yeah, okay. That's what my problem is. Okay, sequence counter. Good. I'm glad I was able to find something beforehand. But yeah, the move is actually a copy. The move is a copy. It doesn't actually remove it from the ACC. It's still there. All right, plot. No, she won't understand. Of course she doesn't. Why would you expect her to? Just keep working. I feel like I'm learning about the people behind this and their design decisions, the thoughts that went into figuring out how things should work. Those people feel very close to me now. Is this computer like changing you, like changed him in some way? That doesn't seem to be great. Okay, so we have in and then 2 outs. We have a bunch of these here, so that's cool. Sequences are 0 terminated. Write a sequence, read a sequence from in. Oh, we have to read a bunch. Okay. Oh, ACC is accumulator. Okay, that makes a lot more sense. Progress is pretty good, I think. Oh wait, did I lose my... Why did music turn off? Let's get that back going. It's thinking about it. Okay, read a sequence from in. Write the sum to out.s. Oh, write the length to out.l. Oh, interesting. Okay. So basically, does it have shift right or left command? I don't think so. Here, let's take a look. This is our documentation. So we have some jumps. The what does it mean by negated? Oh, this is it adds a sign to it. It like adds a negative sign, or it reverses it. If it's a negative number, it becomes a positive. If it's a positive, it becomes a negative. Okay, yeah, got it. Okay, that makes sense. Multiply by -1. Okay, got it. We have subtract, add, save to backup, swap backup to AC to the accumulator, move from a source to a destination. We have a no op. We have a label. There's a comment, and that's it. That's all we can do. So I don't think that there is a shift. I don't see it in the documentation. That doesn't mean they don't have it. Like I wonder if they have like hidden things that are that are hidden out of documentation. Okay, so basically, let's do. We have start. If you are, so let's move up to ACC. Now, if you are a 0, okay, so sequences are 0 terminated. Read a sequence. Okay, so if you're a 0, I want to mark that, like figure out how long something has been. And like we're done. If we're not 0, then we continue summing this. Okay, so if we do okay, so if you're equal to 0, so we know if you're equal to 0, let's jump to done. If we're done, I probably want to move 0 right, because I want to, yeah, you can have a core getting the numbers and just adding 1 to the accumulator if the number is not 0. I was thinking about having the accumulator over here and just like adding 1 over, just sending 1 or 0 over here, and it just accumulates. Then output and reset the accumulator when it gets 0. Oh yeah, that makes sense too. Oh, so instead of move up, oh yeah, so instead of move up 0, we can then we can add up. Okay, so I can add up to the accumulator here. If we're done, I want to move right, move 0 right, so that way I'm just like continuously doing that. I can also do, have the backup be the accumulator too and sort of like play with memory that way. Why has Pretzel just like suddenly stopped knowing how to like continue music? That seems weird. Let's try playing again. Okay, so add up. If we're done, move 0 right. So okay, let's use this as the accumulator then, right? So we're gonna say duplicate the stream, move down, read for logic first, then add up, or in the L, you read for logic and then add 1. Duplicate the stream. Oh, like literally take this. Oh yeah, that could work. Yeah. Okay, so we could just say move up, down. No, move up to ACC, move ACC down, move ACC right. Okay, so then you are, because L is just the length, we'll just say, we'll just do a start, and I want to, I have to move you to ACC, don't we? I have to move left to ACC. If equal to 0, we move to end. Otherwise, we continue on. And I guess to label this to make it easy to see, we'll have this be continue. Well, this is the length, right? So I just want to move left to ACC, not equal to 0. So continue. We're going to swap. We add 1, and then we jump to start, and we continue on with that. If we reach the end, then we're done, right? We want to swap, move ACC down, and then I want to reset the ACC, which is clear. Oh, what was it again? Negate, neg. Neg. And then I start over again at start. Over here, I'm doing this as the sum. So this was just the length, right? Neg does not equal. Oh, right, you're right. Neg is just negative value. Oh yeah, we just write 0 to ACC. So ACC move 0 ACC. Oh, you're right. We need a save of some kind, don't we? Move left ACC. Like save that too. Okay, so move left to ACC. So we get the number, we move it left to ACC. If you're equal to 0, we've ended. So if we end, swap our backup. Oh, then before this, I want to save. Yeah, okay, so in our, yeah, okay, so if we're equal to 0, we end. we swap our back with the ACC. So that's our actual accumulator. We move it down. We reset ACC and we save so that they're both zeroed out. However, if we're continuing, we swap ACC with our back so we know what our accumulator is. We add one and then we immediately save it. So that way we have our accumulator there and then we jump back to start. Okay, I think that's good. And then here is going to be this one. So I guess we can just do move up, down, move up, down. Okay, for you, we have to accumulate the number, right? So we're going to do start. So sequences are 0 terminated, so it's gonna be the same thing, right? Except instead of adding 1, I add this number. So I want to move up ACC. If you're equal to 0, we end. Otherwise, we're going to jump to continue. Okay, so if we're in end mode, I want to swap with what we have in our backup. I want to move ACC down. I want to move 0 to ACC and we save, and then we're back to start. And then we want to jump to start. If we're in continue, I want to swap. Oh, wait. I want to swap, but I lost it. So I need to move the accumulator down twice. So then add up and then save. And then I think we're done. Maybe this will work. Let's find out. Nope. Okay, what's going on? Okay, 35 comes in along with the 0. So the first okay, so 35 is here. We add up, which is 35. Also, you are 35 now. Continue. Okay, we save. So that's the 35. Okay, so then we start, move up. And then you're continuing, so we add 1. Okay, that's good. Then we save, so you become 1 there. Jump back to start here. We got a 0 here and a 0 coming in here, so... Okay. Okay, 35 is coming out of here, and then 1 is going to come out down there. So that makes sense. Okay, so the first one worked fine, if it's a length of 1. And our second one is going to be a length of not 1. So we have 62 coming in here. So I move that down. I'm still in end state. Oh, out S. I don't want you to tell me the answer, but especially if you know it. But like, how is it? Because like I want like pair programming type things would be good. So if there's people who don't know the answer, who want to like try jumping in and give suggestions, I think that's good. So think of like a good balance, if that makes sense. Like for us all to sort of work together and figure this out together. That's why I put the what is it called? That's why I put the back in the continue method, you're adding up, right? Let's take a look. So in the continue method, we're adding up. Up is, I'm trying to move ACC down twice so I can add it up again. So move up. Do all pods have the same reads? Maybe, well, probably not because it's wrong, right? Also, why did I get out 0 here though? Because I'm moving down at some point in time when I'm not supposed to. I wish I can set backwards. But it's too much like a real thing, isn't it? Okay, so we have move up to ACC. So we have our 62 comes into here. That gets saved into here. And then we move 62 down here. So move up to ACC. Oh, I need a nil read. Do I, am I doing that? Let's see, swap, move ACC down, move 0 to ACC, save it, and jump back to start. Move up to ACC, go to end or go to continue. Continue, we swap. Do we need the swap? I do, because I need to know if each one individually is a 0 or not. We add up. So I move up to ACC. Now I get twice down. So we add up and then we save it. So it's back to the backup. And then that goes back up to here. So move up to ACC. In the end path, else you're reading only once. Okay, so what's happening here? So we swap. So back up to accumulator. We move ACC down. We move 0 to ACC. So reset that. Save. Oh, you're right. We need to, because that one, yeah. Jump start. So yeah, I need to, okay, you're right. You're right. Before we jump to start, we need to move up to nil. Let's see if, yeah, that does it. Thank you, Finwo. That was harder for me to like sort of see based upon what you were saying, but yeah, if we walk through it, it looks good. All right, signal edge detector. Can't believe it's been another hour already. It's already telling me that it's gonna run another ad break in 5 minutes or so. We can get a little bit going with this. You know, that's perfect. Yeah, the guiding is perfect. I like the leading questions side of it, because then we all learn and we all can get better. All right, plot. Days and days and days, cycles and cycles, and just one after another. I'm sick and tired. People who don't respect me. Time to pack it up. Getting upset about things? Is this like changing his personality? Read a value from in. Compare value to previous value. Write 1 if changed by 10 or more. If not true, write 0 instead. The first output is always 0. Oh, okay. So it starts with 0. And then we want to see like, okay, if you're 10 or more. Do I need to negate the first output to know, okay, to know what that is? Oh, interesting. Okay. All right. Well, we have an ad break coming up, and I can only snooze it so many times. So what I think we're going to do is we're going to take our hourly break now. Here, we will put on our cat. I think the cat cam hourly break is good. So we'll do cat large. And I will be right back after this thing. You keep a separate core with just the state, so you can initialize the state and then enter something like a while loop. Okay, we'll take a look at that when we get back. So I will be back in around 3 or so minutes. See you. We'll see you then. And there they go. Okay, I'll be right back. All right. Ad break ended. I got you. We got the pet the cat going. All right. So let's see. So you were suggesting we keep a separate core, which is the state, so we can initialize the state and then enter something like a while loop to do something like that. We have a bunch of cores that we can use. All right. So just to remind ourselves, read a value from in, compare the value to the previous value, write one if changed by 10 or more. If not true, write 10 instead, write 0 instead. The first output. Yeah, so we can basically use you as a state. I wonder if I can like basically if I use you as like a state. Should I do like copy to state, copy down, and then I can like ask you to do the comparison, and then like we have a new value here. So one if changed by 10 or more. If not true, write 0 instead. Our first output is already 0. Okay, so let's say we just start with, I don't know if we want to use a label or not, but we'll just go ahead and start with that. So we'll just move up ACC, move ACC right. Okay, so that way we can have you over here and we'll capture you and just use you as a state. So let's just move left to ACC and then we'll deal with you later. Okay, so compare the value to the previous value. So maybe you're always the previous value. Huh, interesting. If we say that you're always the previous value, maybe I move you down here. Right, one of change. Okay, so I want to subtract by 10. No, I need to subtract by the previous one. So then I want to move another one in. Let's move up to ACC. And if I sub right, so that would mean we now need to move ACC left. Okay, so if you change by 10 or more, okay, so then if I, because I could have, if you are less than 0, I need you to be positive. I need you to be positive. Right? But no, that doesn't work anyway. That doesn't work. I can't always sub. I think that's the problem, right? Because like because we have negative numbers in here. So if we start like 0, 32, David, hello. How are you doing today? What happens if you just run it like that? Yeah, we could try it. So if I sub right, like here, if we step through this, we can see like what's gonna happen. So we start with 0. So we store you, and we store you over here, and then move ACC right, so that way you're stored over here. Move up to ACC. However, in this first one, we need to move this. Oh, so like this one is starting with 0. Oh, that sucks. You'd move the core to the middle row. You move the core to the middle row so you can move up ACC, move ACC down, move ACC down in the top one. Yeah. Yeah, it's like shift over a little bit. You can use a core to get the absolute value. Yeah, we can do that too. Yes, that might be a good idea. That we can use one for comparison, one to save without having to worry about using the backup. Yeah. Which I think is along the same lines of sort of like where Albert, you're going with that, is like we can start using cores for little functions, like using the cores as a function, essentially. A little logical piece of code. So basically, I want to oh, but how do I handle the first one? If you're 0, I kind of want to I just need to send this out because there's nothing ahead of it. Except we start with 0 here. So can we just pretend we already had one? Would that work? Yeah, we can just use that. Yeah, we could just start there and just pretend we already have this. Okay. So compare values. All right, so one, what do we want to do here? I want to take you. I wonder if I want to do this down here. Value to previous value, rate 1 of change by 10 or more. So I need to get the one that's up. We store it into state. Okay, so what we're thinking about doing is like maybe having state over here or over here. And then I can have something that turns it into the output must be 0 even if the first value is 15. Well, the first value is always 0. So the first in is always 0 and the first out is always 0. Okay, so I wonder if we should just have this be the state, right? And this be our core logic. So if we do something like that, move up the ACC, move ACC right. We now store ACC in there. Okay, read a value from in, compare the value to the previous value. So I want to compare what I'm being passed in to previous. Oh, but we don't have... previous here. You could have a nil read with a 0 write, then a loop of moves. We could do that. We could have a nil read. I can literally just cheat. And we just say okay, so I move in, and then if you're 0, we just write out 0. Then after that, we never go there again because we jump to 1 level down, and then that's fine. That'd be interesting. I don't know if that's a good idea. Okay, so yeah, at the end, ignoring the first result, we could just do that. We could just have like a like move 0 down, and then like we have our loop, and then at the end of the loop we have jump loop, something like that. I don't know if that's a good idea. That feels hacky. Okay, so I keep you in here. I want to take this, and then we're gonna read in 0, and then I need to read in 32. Okay, so I need to read in, we read in the first number, and then we read in the second number. So read in the first number. And hand it over to here. Read in the second number, hand it over here, and then the first number comes down here. So move up to ACC. Move ACC right. So that's the first number still. And then the second number comes over here. I don't like this. Okay, so if I want to subtract u by, okay, so if I move left to ACC, that stores in 0 here, and then I want to subtract the next one, so I want to sub left. Oh, but I need to make sure that whatever this is positive to then subtract them, right? No. Compare value to previous. I don't want to blindly subtract it, right? I want to. Okay, so if you're, let's see, 8 to -3. If I take 8 and subtract -3, that doesn't become +3, right? It's not like that would become 11. My brain is suddenly like blanking on how math works. Hold on. So like 8 minus -3. Well, if it's 8 minus 3, that would be 5. But it is not minus -3. This is minus minus. Don't the signs counteract? So that would be essentially +3. Is that just me forgetting how math works? Wait, so if I have 0 minus 3, and then I have... I don't know how to do... Okay, 8 minus... Oh yeah, okay, so I'm right. So yeah, that becomes 11. So yeah, I can't just do blindly... Okay, wait. If I'd have 8, I subtract a -3, that becomes 11. That is greater than 10. So if I then subtract... Oh, then I want to positive that. And then subtract 10 from there. Okay, so then that's fine. So I sub left. Now I want to take this number and I want to make that positive no matter what. So then we want to move ACC right. And then your job is to now make you positive no matter what. So move left to ACC. If you are I guess like if you're less than 0, so jump less than 0, like 1. No, be relative. That's not going to work. Jump less than 0 to negative. So if you're negative, I want to negate. So I want to negate whatever's in ACC. Otherwise, we don't do anything at all. Okay, so then we have our end. And we're going to move ACC left. Okay, so move ACC right. Move right to ACC, so that way we put it back into here. Now, now I want to... I probably want to just move this down so I can have another check to see if it's less than 10 or not, to give myself more room. So if I do move, I guess I could move right down. So now we're down here. All right, let's double check this. So let's do move up to ACC, and we can just see what's going to happen. So we do... The first one just comes out right away, which I'm not sure it's a good idea anymore still, but whatever. Okay, for 32 comes in here. I moved left to... Oh, because we got the zeros here. So this is a terrible idea. Hold on. I don't want to do this anymore. Okay, 0 moves into here and then is going to move into here. Okay, so sub left. Okay, so we moved you into there, and then we're going to get the next one. So 32. That becomes negative 32. We move you to the right. Negative 32. You're negative, so we negate you. You become positive 32. We move you back over here. And then I want to move you down. And so then you get stored. And then meanwhile, we moved, so this was all 32. We have 30, which was the next one. Oh, but that should be 2. And I've already lost it. Okay, so no, this is not right. Okay, so what I want, let's see, what do we need to do? We need to, I think the general idea is right, but I'm doing it, I'm not keeping the previous one around. And this is what you were talking about, Finwo, with the state, like keeping the previous state. I could move the same one twice, but I don't think that's right either. I could move this one either down or left and then just like move it back. I wonder if we do something like that. If I take up and I move, okay, so I move you right, and then I also move ACC left, and then I also move left to right again. Is that what I want to do? Probably not. I probably want to move both of them, one right and then one down. And then we do the math here. So I probably want to do down. So, okay, we move up into ACC, and then we move you right, and then we move you down. So we have the current one and then the current one. So we have, I could do comments. I don't know if I need to for this. I might need to start doing comments for these though. Okay, so we get right. We then immediately take the right. If I just immediately move this down, I'm not changing anything. I'm just moving all the logic down one by one. But that might be what I need. So if I move left down, so you're ready to give me whatever you have in here whenever I want it. Okay, so move left down. Okay, so over here, so 0 comes in, 0 goes over here, 0 goes down here. So we have 0. We have 0. So that starts with 0, right? I then need to take the same one. So previous, right? And I need to then subtract them together. So I then need to do a sub of the previous one. But this is the current one. I have to make sure that this is off by 1. Now it is 0 to begin with, but that's what it starts as. So it's almost like I need a null. Smooth. It can't just be move upright. Unless I ignore the first one. If I move left to nil, and then I sub left, that will make that 32, which will not be correct. Unless we start if I start by moving ACC right and then move up ACC. Now I don't need to move left nil because you are 0. You start with 0. Now we sub left. That gives us 0 minus 0 is 0, but we don't know that. It could be negative. So now I want to send that to the right. So move ACC right. We throw you in here. And then we move okay, so the only negative here now is that I don't have that state that you were talking about. I do have to use backup because I lose the previous one here unless I can grab it multiple times. So I moved you back over here. Yeah, back up. I mean, whatever way works out. I mean, that is so programming, isn't it? Although, what if I flow it instead of moving back to here? What if I just move? This is the difference, right? So then you become positive. You become a positive number. I then want to subtract by 10. So move accumulator down. I want to subtract 10. So move up ACC sub 10. Then we compare this, right? So we sub 10 if you are less than 0. So jump less than 0, jump to less. I guess like, okay, so jump to less, or if not true, right? So jump to else. Else we're gonna move 0 left. Less we're gonna right, so move 1 left. Then here we're just gonna move right down. So that moves down like that. Okay, so move up to accumulator, sub left, move. I've lost myself in the logic. So now I need to step through and see what's going on. So we get a 0, so move you right and down. So here's the previous one here. And then the next one, the previous one is being stored. Okay, so sub left, 0. Move this right. So 0. If you're negative, jump to negative. Otherwise, jump to end. Okay, so we have a 0 here. Meanwhile, sub to 10. If you're less, move 1 left. Uh-oh. I think I got this wrong. You're supposed to be 0. Okay, so let's do the second one then. So 32 is coming in. Okay, so move that 32 into the accumulator. Move it right. You just moved it down, so you're here now. Also move it down to here. So we're going to sub left, which is going to be that 0. Move it to the right, which is going to be $32. Okay, so we just move that down. We have 32. Sub 10, less than, move 1 left. Okay, so wait. This one is 32. When did we ever have... Okay, so here's 32 coming in. So 32 got here right away. 32 here waited a little bit. Okay, so I first sub left by 0 here. And I moved you to the right. Oh, and then I lost the... I'm off by 1 here. I need to... I'm not doing 32 by 30 anymore. I did 0 by 0. I have 32 because I did 32 minus 0. Yeah, so like then, okay, 32, I subtract 32 from 30, so that gives me -2. Rugmat, hello. This game is called TIS 100. A hand -2 over there. You become 2. Oh, but look at this. Okay, so already previously I was broken. What do you have to do? So it's a puzzle game. So if you've ever heard of Zachtronic games, it's one of those. And the idea is that we are programming assembly to sort of figure out the patterns and do that stuff. Do you first figure out the pattern? Kessor, hello. How are you doing? Do you first figure out the pattern of the input, or you just sort of start writing code immediately? Yes. Okay, so I am not... Is the problem that I'm not waiting? I'm losing the previous output, aren't I? So like I'm checking 0 from 0, but then I'm checking 32 from 0, and then I'm checking 30 from 32. Yeah, it gives me the instructions up here. I mean that... It's like, okay, so I'm moving that first 0 down pretty fast. And then I'm moving... Okay, so then I get this 32 here, and 32 is about to come down here. So then 30 comes after 32, so I have that over here. So 30 and then 32. That seems to be fine. And we are about to get 1 out for the 30 to 0, so that's fine. And then the next one is the problem, right? So 30 to 32, which is 32 coming here, which is wrong. So what happened there? Okay, so 32 and 0 gives me 32, which is correct. And then I get 30, and I want to subtract 32. That gives me -2. -2, negative. That gives me 2. So move that down, 2. Oh, and I already... Okay. Before we even got to that point. Claudio, you played this game many years ago. It was great, but your brain got burned every time. Yeah, puzzle games generally get me like this, but I want to get better at them, which is why I'm playing with all of you, because you're going to help me get better. That's the idea, right? And hopefully we'll all get better together. Okay, so it's before we even have the 2 coming in here. Because what is it? It's this one right here. So 30 to 2, 30 to... Okay, so I'm passing 0 down, which is that first one. Then I'm passing 32, which is 32 to 0. That makes sense. Then it should be 30 to 32. So here's 30. On a sub left, that gives me 2, right? Now I already have, okay, so I'm moving the 1 in here, and then I have another 32 here. Do I need to wait on this one here? This 32, that one is coming to here. This 32 down again is wrong. What happened here? Why are you there? So we get, okay, 32. Move left and there, and this is fine, the first 32. Jump to end, move that down. I need to read this. Move up to the accumulator. You're just staying there. I thought when I moved up to the accumulator it was going to go away, but it just stays there. So now I get a 32 back in here again, and it never should have. Oh, wait, less. Oh, do I need to, am I just forgetting to jump back to start? Oh yeah, that was it. I forgot to break out of the loop, and I was dropping below. So that's good. All right, next segment. It's just like programming. It's like that's the equivalent of like missing a semicolon. Oops. Or as actually more of the equivalent of missing a break in a switch statement. So fun. Okay, next up. We have a bunch of inputs. Thank you. Interrupt handler. Read from input 1 through input 4. Write the input number when the value goes from 0 to 1. 2 interrupts will never change in the same input cycle. What? Write the input number when the value goes from 0 to 1. Okay. Oh, okay, I see what it means. So if it's 0 through 1, this is 4. Okay, oh, let's take a look at plot. My sister was over for the holidays, I think to check on me, make sure I haven't gone off the deep end. I know it caused some worry. Her kids saw me working here and suggested I could surf the web for TIS 100 specs. So even kids are on the internet, online, blah, blah, blah. It's a racket. I don't care about the information superhighway, and it never will. Yeah, it just wants to know which input had the change. That's what it is. So we just have the accumulator, but I need to know. Oh, that's fun. It's not how many inputs changed, it's which input changed, right? Because like when this in one goes from 0 to 1, that's an out 1. When this input 2 goes from 0 to 1, it changes to a 2 out. And so these will never go from 0 to 1 in the same cycle. So we just need to constantly check the previous one that we got and see if it's a 0 or a 1. Yeah, the number of inputs. So like this one is 1, this was 2, this is 3, this is 4, but it's always going to give me 0s or 1 as input. So if we do how do I want to do this? Yeah, only a change from, because we see this one like input 4 here is 0, 0, 1. So that's when we put a 4 in here. And then it's a bunch of 1s back to 0. That's still not the case. And then back to here. So it's only from 0 to 1. So I need to check to see if the previous one was a 0. Okay, so if the previous one, if it's a 0 and the previous one, I could start, okay, so let's, if we start, we know we're all 0s at the very beginning, right? So I want to check to see if you're a 1 now. So move up to ACC. If your jump equal to greater than 0, so if you're 1, ACC should have the previous number, but in order to compare it, I need this, right? I need to move it up into here. So I would need to save it. It's basically a double, it's a double if. It's an if within an if. So if you're greater than 0, that means you're not a 0, so you're a 1. So we're going to check. If we're checking, we also have to now swap with what we had previously and then check to see if you're now 0. So equal to 0. And then we flagged it. We interrupt. So if we interrupt, we want to move, let's say, 1 down. If we're not interrupt, we have to do something else. We have to jump to somewhere. I guess we move 0. Do I move 0 down, or just move, do I just jump back to start? I don't know. If we interrupt, we move 1 down, and then we're done? I could move it down to save it too. That could be the other thing, is like we could save it below as well. Oh, if we move 1 down, then I need to... We swapped... Swap and save? Does that make any sense? So whatever ACC is, make it to save. Make it the new save. And then back up to start again. So, okay, here. If we're... Oh, save. So, 0... Oh, I want it to be... If you're checking... Okay, so if you are a... Huh. Input 1, greater than 0. Oh, check. Otherwise, we want to jump to start again. So move up. So then we have that 1, check, swap, so it's a 0. If it was equal to 0, move 1 down. Oh, now you're just waiting for me to do something with this. So then I want to move up, right. Now, if I do this entire thing with everyone, and the only difference is this like moves 2 down, this moves 3 down, this moves 4 down. This sort of is a pain, but okay, so we move you right, which means that you have to handle, at some point in time, we have to handle all of them. They can all be 0s though, which means that we have to have an else. So if you check to see if you're a 1, we either interrupt. Oh, so we have to have an end. We have an else. So an else is going to be a move 0 down. You'll probably have an easier time debugging just the rightmost one. Oh, because it's or even the third row, which is a straight path down. Yeah, we can just debug this one first. Yeah, that makes sense. Okay, so if we move up, down, so we just move these down, so we either get 0 down. Let's just try simple, right? The interrupt will cascade into else. You're right. Move up, down. So I want to jump back to start again. Let's do what you were suggesting though. Where's my mouse? There you are. Let's try just doing this one here. So we're gonna jump, start. So if we run you, so okay, you're zeros. Okay, so then we have 1. Oh, but you crashed before that because you're supposed to be a 4 here. So I can't just debug you. Okay, so 4. Okay, so I need to handle all of them coming together and sort of combine them into so I need to combine them into the one thing. So then I need to move up to down, and I need to move, okay, so move up to the accumulator. I don't need to compare them. What if I just add? Because only one of them can change in the same cycle. So what if I just add? So I'm okay, moving up right to here. I then add up, add left, move ACC, sure, down. And then I want to move 0 to ACC. So just reset that. And then we're just going to move up right. We're going to move up to down there like that. We're going to move up to down, move up left. And so I want to add left, add up, add right, move ACC down. Where did I have a missing comma? Move ACC down. Oh. Huh. I wonder, it usually tells you if there's a problem. Like if I did that, I wonder if that's gonna have an issue, or if it doesn't matter at all. And then we want to move 0 to ACC. I wonder if that would just work. Close. I have bad logic. I didn't have all the logic be correct. So let's just okay, so then this is going to be move 1 down, move 2 down, 3 down, 4 down. What if you run? So this one, this one's supposed to be 3. What did I get? I got a 0. So in 3, oh, I need to reset my, so on interrupt, I move 3 down, I don't need to swap. I don't need to swap save. I need to move 0 ACC. And then I save. That worked on the first one? That did not, I don't think. So if I check, okay, so we do an interrupt. Oh, wait, I don't want to. Do I just want to swap again? Oh, so I got a 3 when I was supposed to get 0. So this is if you're greater than 0. Okay, so I want to swap. And then I want to move 1 to ACC. Probably will leave the ACC with the value of the input for that run. Yeah, maybe we just don't do swap. We just jump back to start. Okay, so. Okay, much better. So then we get to here. And you're supposed to be a 3 now. So you were probably, let's see. If I check and else move 0 to down. Okay, so you were a 1. Right? No, you were a 0. Is this one right here, right? So it's 1 0 1 1. Okay, so I want to check in. Okay, so we have a 1. We have an accumulator for that. So we get 1. Oh, your backup was 0. Your backup was 1 still, so it doesn't know. So I need to interrupt, move 3 down. Whatever the previous one was. So I swap back up to the accumulator. I interrupt, move 3 down. Okay, so if you're that one, move 3 down, jump back to start. Swap it back after jump in check. Yeah. If I jump to interrupt, I could swap back there. That doesn't work. Figure code fails with input values other than 1 and 0. Yeah, but our input values are clearly always going to be 1 and 0. So like I don't have to worry about I don't have to worry about that. They're always going to be 1s and 0s. I move 3 down. Almost like, do I want to just save? whatever this was. Like instead of swap, I save. No, that's not what I want either. You have 2 branches, jump from checks, maybe swap in each of the branches. Yeah, so we have move up to ACC. So check swaps, and then interrupt. Okay, so we swap. So this became, if this was it was a 0, I want to put it a 1, and then I want to keep it to be whatever it was previously. So I move you down, jump start. Oh, the cat does not let you see all. Yeah. Sorry about that. But Zilby's like that. Cats don't let you see all the inputs. That's the that's how cat debuggers work. So both an interrupt and an else swap it back. Yeah, we could try that. So I could try swap. And now it thinks, okay, so it got when it was previously a 1. If you're an interrupt, I want to, if we're interrupting, we know that it was previously a 0 and now it's a 1. So I need to make sure that our previous one is now a 1. So we want to save you. Do I just want to save instead of swap? No, that's the same problem. And interrupt. Okay, so when we check, we swap to what the previous one is, which does make sense that I want it to be a swap again, doesn't it? But we have the same problem, don't we? So I want the first thing that we do is swap and start. So this is, okay, so in 3, we had a, we had a 1. Okay, so hold on, let's see what's going on here. So in 3, we have our first interrupt. Okay, so we move you up there. We check. We swap. If you're equal to 0, we interrupt. We are equal to 0 now. So we interrupt. I don't want to swap back because we want to keep that our previous one was 0. I need to make sure that you then stay there. If we run you again, much better. So now you're supposed to be, okay, 2. So now let's copy this logic to everywhere again. So 1, 2, 4. Hey, it's like a gnat. There we go. It works. All right. Okay, where are we? We are now here. Okay, and perfect. Twitch wants to play an ad and do another ad break because it's been another hour, which is crazy to me of how fast we're moving. 12:41. It feels like we're moving really fast through time. Okay, I'm going to go grab a quick snack, and then I'll be really quickly back. I'll be back quickly. So let's go ahead and put our Zilby big picture up for ad break. I should actually add in a text break. You can barely see that. Put it down here. That's a little bit easier to see. And then we'll be back soon. All right. I will go ahead and start the ads now, and then we'll be back in a few minutes, and I will see you then. Bye. Still be. Okay, hold on. Zilby decided to sit on my chair. Come on. Cat break. you can go back to your normal spot. All right. Yeah, Zilby decided to spend the break on his chair instead of in the, you know, the break zone. All right, so let's continue. Next puzzle. Oh, simple sandbox. Huh, user segment. Is there... Am I supposed to be putting stuff in here? Huh. Wait. I have no idea how I'm supposed to do this. Yeah, this looks like a sandbox thing where I can just do whatever I want. I mean, I guess that's pretty cool, but I don't know how helpful that is. Oh, is this trying to... Oh, I can create a new... Oh, I can create puzzles. Oh, cool. Okay. I don't want to create my own puzzle. Okay, so there's sandboxes and puzzles. Let's go with their puzzles. Create new program. Okay, so signal pattern detector. First plot. They heard a noise from the garage, but it turns out it was nothing. So now that I have plenty of free time, I might as well get back to this. Keep my skills sharp while I look for a new job. Okay, so he lost his job. He's hearing things from the garage where this computer is. Is this computer like alive? Is this computer like some evil creature or entity? That doesn't seem... This doesn't bode well for us. Okay, so read a value from in. Look for the pattern 0, 0, 0. Write 1 when the pattern is found. If not true, write 0 instead. Okay, so I want to read 3 things in. Oh, interesting. Okay, so I want to read 3 times in. If all 3 are zeros, then we're good to go. Maybe just one thing, the number of zeros so far. Yeah. Oh, yeah. What if we do that? What if we just take a 0, and if it's a 0, we move 1 down, and then we just add 1 to it, and if by the end it gets to a 3, oh, is this modulus? This is basically modulus. If it's a 1, I just add 1 to it, otherwise I reset it to 0. I don't have to like do a full like implement modulus. I don't think so. So if we take you, if you're okay, so what if I just do this? If you're a 0, I then move 1 down. So we'll move up to, apparently we don't need the comma. So move up to ACC. To our accumulator, we are going to check to see if you're 0. So if you're equal to 0, jump to 0. Otherwise, I move 0 down. So I guess like move 0 down, jump to start. So on 0, we're going to move 1 down, and then it jumps to start automatically. The output column shows that any sequence of 3 zeros is valid, even, yeah, exactly. So what I'm thinking here is that I just, okay, we're gonna have to start. We add up to the accumulator here. Now, I kind of want to check to see if is that true? How do I want to do this? Okay, move 0, we move 1 down. Okay, so I just want to, yeah, any non-zero will reset the count. That's pretty easy, right? If I add up, okay, so if I add, do I want to check to see if you're a 0 or an up? Yeah, how do we count in the first place? If you're a 0, I want to reset, or I want to reset to back to 0. So it's not, if it's not just adding it, I want to reset it. So if I move up to ACC, and then if we have a 0, you can move 1 down to add or move 0 down to reset. So yeah, so here's 0 down to reset, right? So if you're a 0, okay, so if you're equal to 0, we reset. And reset means I want to move 0 to ACC and save. And that's it. And then also we're gonna have to move ACC down and then jump to start. If we're not equal to 0, then I want to add ACC. No, I want to, I need to restore from backup to whatever. Because, okay, I need the count. I need the count. I could use one of these too as sort of like a state to like send something over there. Okay, so basically move up here, check to see if it's a 1. If it's equal to 0, then we're resetting. And reset means we just, I don't have to move 0 to AC because we already know that you're equal to 0, right? So we just save that to reset the backup. And then we also just move this down because you need to be a 0. And then jump back up to start again. If you are not 0, I want to add you again, which means I need a temporary storage here, which we can use over here. So we can just move up to ACC, move ACC left. So we'll just store that really quickly, and then we check to see if we're resetting. If we're resetting, we're good to go, and we come back up to here. If we're not resetting, we want to jump to look for pattern. So we're continuing to look. I want to add. Now I moved up to ACC, so really I want to swap and add left, which means I need to now move ACC right, but then I need to drop this. So before I do that, we're going to move left to nil. We add left, and now I need to check to see, I guess, like, so now we're running out of move, so let's now just move ACC down. Let's add left, move ACC down, and then let's also save to save our backup. So now we're going up. Okay, so I run out of space, which is okay. Down here, we're just going to get a number. It's either going to be 0 or it's going to be 3 or 6 or 9. So I kind of want to implement modulus here, don't I? So if I subtract 3 and you're still above 0, I want to continue trying to subtract 3 until eventually we get 0 or below 0. Why 3, 6, 9 and not 4, 5, or 6? So, wait, is that true? If I add left the number of zeros, oh, you're right. So, oh, okay, this is gonna be the number of zeros that we've now gotten in a row. Oh, and it's really just the last 3. Okay, yeah. So if I subtract 3 from this, so if I move up to ACC, if we sub 3, if we are greater than 0, we jump to greater. In greater, we're going to move 1 right. If it's not greater than 3, then it's less than 3. I probably want to, do I want to reset it, or are we just good to go? So here, this is like 0, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then that starts at 0 again, but I'm moving that down here. Okay. So then, okay, if this is greater, okay, we do that. Otherwise, it's just 0, right? So otherwise, move 0 right, and then jump relative. It was like JRO -4. I don't like it. And then that goes back up to the start. Well, I have my accumulator up here, don't I? So this is the accumulator that is looking at zeros. And if it's ever less than 0, if it's ever a not 0, it resets. So this is the accumulator. And then this is just checking to see if the one that's moving down is, we have had more than 3 zeros at a time. Okay, I think we're fine. So we move you right, and then all I want to do is I just want to move left down. Oh, that's really close. Okay, so most of it is working. So this one is, we got 3 zeros in the first place and we got 0, but then everything else is working. So this feels like an off by 1 error. Yeah, off by 1 error. All right, what did I do wrong here? I do move left nil if we're resetting. Otherwise, I am adding left here. So I am taking both of these. So we get that. We have the 0 coming in. Zero comes in left, equal to 0. Oh, wait, you know what? Because I do this weird. So move up accumulator. So you're a 2. If you're equal to 0, we're a 0. We're not equal to 0, so move 0 down. I kind of want to do the opposite. I don't like this anymore. So I want to move 1 down and then 0 down. So then move up accumulator. Oh, but you know what? It totally makes sense. Because I'm just adding these. Okay. So if it's a non-zero, we move 0 down to add 0 for that. Okay, so we move up to here. So this is going to be a 0 for the 2. And I move up into accumulator. I also move that to the left to store for storage. I then check to see if you're equal to 0, we are resetting. Otherwise, we are looking for the pattern. So I kind of want to adding. So add. Okay, so if we get to here, we're going to swap back to what you were previously, which you're starting at 0. We add left back into here, which was that should be a 1 that we move down. So we add that back in. We move the accumulator down and we save it. So the problem is, okay, 2 comes in. You're not equal to 0, so you move 0 down. Oh, what does the move left nil do? It basically takes the output that this is going to give and drops it. It's basically the equivalent of moving to what is it called? Dev null in Unix or Linux-like systems. Okay, so here's our first 0. So we move a 1 down. So here's that first 1 here. But we're still in the resetting from the first 2 that came in. So move left nil. So this 0 gets dropped. We jump back up to start. We move this into the accumulator. Move the accumulator left. So moving over there for storage. We check to see if you're equal to 0. You're not. So now we're going to jump to add. I want to swap you. So the 0 and a 1 come down. We add left, so that becomes a 1. And then we move this down. Now 3 is already in here, and so there was a second 1. Okay, so this was that second 0 that came in. So this would be 2, so this is fine still. So really it's after we get that next 0 coming in. So here's the first of the 3 zeros that we're looking for it. Yeah, left to trash, exactly. Okay, so 0, we're about to move the 0 down. We're now waiting for this 0 to move down. We're in the middle of the resetting from the 4. Okay, so move up to accumulator. No, we still, okay, wait. I think we already got the off by 1. Shouldn't 0 be a 1 from top to bottom, not 0? Wait, which one? Shouldn't 0 be a 1 from top to bottom? This is 0 for moving 1 down from here. 0 be a 1 from top to bottom, not 0. When moving from top to bottom on a 0 input, it should be moved 1 to the bottom 1. Yeah, okay, so we moved up to the accumulator, so which was whatever the input was. We moved that into here. And then we move a 0 down. We just basically say, okay, move a 0 down. We converted this into we're converting whatever this was into a 0 or a 1 and moving that down. And then giving this, now we're dealing with that. but we're already off, I think. So we've accumulated 1 here. So this is the third 0. And now this is the fourth 0. Okay, so that becomes a 2 here. Okay, so move up. Swap, we have 2, add left. Move accumulator down. Sub 3. Oh. Oh, I need this to be... Oh, shoot. I need this to be equal to 0 or greater. Okay, so if you're equal to 0, greater, and if you're greater than 0, greater. I had a greater than 0 check, not a greater or equal to 0. That's it. Okay. All right. That's a good question. Let's find out. So we have just jump equal to 0, not equal to 0. Oh. We can do less than 0. We can do the opposite way. Yeah, let's do the opposite. So the opposite would be if you are less than 0, lesser. Lesser, so this is going to be move 1 right, jump back to start, move 0 right. There. Same exact stuff, except slightly better logic. Okay. Sequence peak detector. Sequences are 0 terminated. Read a sequence from in. Write the min value to out I. Write the max value to out A. Oh. Okay. All right, let's I am good, damn it. Just as good now as I ever was. But nobody wants to hire old washed up Randy. Not when all the young folks straight out of school work 100-hour weeks for nothing. And I'm lousy at promoting myself. Always was. Paul had Bill. Waz had Steve. I never had that kind of partner. Someone to champion me. It was always Jay. Just me. Okay, now it's just getting too real. Oh, I could have sub 4 too. I could have, yeah. That could have worked. All right, but now we're on here. Okay. Sequence peak detector. Sequences are 0 terminated. Read a sequence from in. Write the min value to out. Write the max value to out. Okay, so. Oh, so okay, it's 0 terminated. So basically, go into a 0, and when we have a 0, we need a reset. Well, that's fun. Okay, so it's almost like I want to take you and send you left and right here. I can't use this path because, you know, dear old uncle screwed up the entire chipset. So that's cool. Hmm. Okay, so if I just take this and I send it left and right, I guess that's the first thing we're gonna do with. So move up to ACC, move ACC left, move ACC right, and then that resets. Okay, so now we can have this start being, let's do min value is I, so this could be the minimum value track. So we'll do our min and our max here. Okay, how do we know what the minimum is? If we subtract it, so if we move you into the, okay, so let's do our start. Here, I'll just label this with min. If we move right to our accumulator, can I compare number with accumulator greater than or smaller? Not really. I can subtract it though, right? So I move our right to ACC. I don't want to move right to ACC. I want to, let's assume that we have our previous stuff in here in ACC. I just want to subtract it right away. So we sub right. And then we need to check to see if you are, so if we have like 3 here and 7 here, 3 minus 7 would be negative. So if you're less than 0 now, so if you're jump less than 0 to new greater. Wait, if this min, okay, so hold on. I want to do the opposite way. I want to, if I sub right and if it's greater than 0, we have a new lesser. Otherwise, we want to jump to keep. So if we have a new lesser, I do. So we're gonna get to that. Okay, so new lesser sub right. For new lesser, I want to. If we have a new lesser, I want to now move right to ACC. So that means I need move ACC left, move ACC left. So just do it twice. Here, I'll skip doing the right yet. So move right to ACC. Now I keep it, right? And then I want to immediately save it. So now we have it saved away. I know I'm not talking about the zeros yet. That's a thing. I guess like, oh, if you're, ooh, wait a second. If you're equal to 0, new lesser. Yeah. Shoot. Because I need a reset on this. it's almost like I need to first check to see if like move right to ACC, if we are equal to 0, we reset. If we reset, I want to save, and then we're going to jump to restart again. Otherwise, okay, so then I need to restore. So swap, sub right, then check to see, okay, if we're equal to 0. I don't want to check to see if we're equal to 0. I want to see if we're less than, let's see. If we have 7 here and you're a 3, 7 minus 3, if we're greater than 0, we have a new lesser. Do I want to swap after this? If we don't have a new lesser, I need to swap again. No, because we already subbed right. I lost it, didn't I? So far, it does look like we don't have anything greater than... Well, I think it says that in the manual that they can only handle numbers between negative 999 and 999. So we know that they can't go above and below that. But they can potentially go above 2 digits. Did I just lose this? I feel like I lost it. So, okay, so we move the right, start from scratch. No, I mean, like, I think I lost the previous number that were in here, like our previous min value. Okay, so we move whatever's in here into here. If you're equal to 0, we reset, which is just saves that and then jump back up to the top. I don't need to jump back up to the top because we're at the bottom. So we're good to go. Okay, so if we are for the min function, we don't need to save the 0. If I'm swapping though, I do, let's see. I move, okay, so hold on. I move right. So whatever, okay, so whatever this is the new version. So like, let's say, maybe you need to save a 99 or something. Okay, so we get past, we don't have, let's say we don't have a 0 in here. We have a number that's greater than 0. I mean, it could be less than 0 too, but we have a number that's not 0 in here. I want to swap it to whatever a previous low was. So that's why I swap. And then I sub right again. So that's why I'm moving it here twice. Oh, so then if I reset, I need to move right nil. If you're greater than 0 after the sub, we have a new greater than 0. And if we don't, we go to keep. Like keep our current one. So our accumulator is after that. Okay, so move right. Okay, so we subtracted right, so we lost. So our backup is completely useless now. After we swapped and subbed right. That's our problem. I'm just talking about the resetting account AC to 0, and the back to 0 will bite you in the next sequence of numbers. Why is that? Because I need to reset. Don't I need to reset whatever it is to 0? Oh, you're right. I need to set it to the maximum number possible. Oh. Yeah. Yeah, that's right. Vivax, hello. How are you doing today? Because 0 will be lesser than any incoming number. That's very true. Are you just working on Git? Nice. How's that project going for you? Okay, so let's see. Okay, so then move right to nil, so we drop that. Now the problem is that we've lost our backup. So because we subtracted from it. So we swapped it. We subbed it to find out. Ooh, okay, so I wonder if we should just return this down, like send this down. So we have either maybe we like send down our new lowest. Or I have to like move this again to the left. So like, okay, so we sub right. No, we can't move that. That doesn't make any sense. We have to say, okay, so this only works here if we have a new lesser. But if we're trying to keep, we're screwed. You should store the lowest, and when you get a 0 termination, you should output that thing and out. Well, thank you for that. Okay, so pair programming at the finest, right? Thank you, drivers. Oh wait, no, I'm the driver. Thank you, navigators. You're navigating super well. Thank you. All right, so if I sub, as soon as I sub right, because I swapped, do I want to save before I sub? Okay, so I move up. Wait, so I'm moving. Okay, so we have, if the 0 comes in here, we reset. That's fine. But I did move you into the accumulator, which means whatever was in the accumulator before was lost. I could. Can I? don't know if I can. I do have the remainder. Okay, so we swap. So yeah, let's see if we have room to do that too. Okay, so move right. Okay, so if it's 0, we reset, and who cares? Then we're just resetting accumulator. I probably want to save that also, and then move the right to nil, and then we reset up to here. Although I probably need to move something down. Wait a second. So this is, okay, 1473, 58. So on the 0, on the fourth one, we put out a 14. Oh, so if we're resetting, we have to move down. It's not that I just reset. I also have to. So I have to end. It's not just resetting. It's ending. So I can do move before. Okay, before I completely lose everything, I have to swap. Oh yeah, this is not going to work out very well for me. I need new logic for this. I've run out of room. Oh boy. So okay, let's restart. If we're gonna get in a 0 or just any number, and I want to send them left or right to do the thing, to do the appropriate thing. Now, I could also do the core logic here for like less than, do greater than, and then they kind of have extra space here and here to do stuff. That might work. And then we can use states for on the left here, and we have states here and here, and we just don't have one in the middle, right? So coming in. Yeah, this might work. I wonder if I should do greater than first, because we have this is our restriction here. So maybe I'll do that. So we'll just do move up to ACC, move ACC right. You can probably have a trigger with the 0 termination in the middle box that will trigger the box on the left and right to send it further. Well, what I need to do is I need to not sum. I need to find out which one is higher. On null, okay, so on a 0 termination, I need to take whatever we've accumulated so far and send that on through. If you use these boxes as just accumulators, they will keep your min and max value, but will not send it further until told. Right. Okay, so accumulator. So if I okay, so if we just Yeah, we're in system design territory. That makes... Okay, so if we just say, I just want to restore I just want to hold that one, right? I don't care if you're... I care if you're 0. I want to ignore zeros. Except that's not true. I need to reset. I need to reset this. So on a 0, it resets it. So we're going to... If I move left to ACC, jump equal to 0 to reset. If we're resetting, I want to set move -999 to ACC and save it. And then we're done. If we're not a... If we're not a 0, we're going to do our check to see which one's greater than or lower. And I wonder if we can just do that here. Oh, JNZ. Oh, I forgot we could do yeah, we could jump if not 0. Right. Yeah, so we could do just jump to 0, jump to reset. JNZ for calc. Sorry, calculate the greater. Reset is right there. No need to jump to it. Oh, you're right. Reset is right here. So we just do this. Yeah, okay, so jump to calc if we're doing that. Otherwise, reset. Okay, in calculation, what if I... Okay, so I moved left, so whatever I have saved is my previous greater. So I want to swap that in. You're my previous greater, and then I want to now move. It would be 0 on the first run, unfortunately. Yeah. For greater, that's going to be okay. Maybe. Maybe, yeah, let's wait until that becomes a problem. It might be a problem right away. Okay, so for calc, we swap this back in, which is obviously starts at 0. And then I want to compare to see if it's greater. So then I want to do a subtract left. So sub. Oh, but I can't sub because now I've moved it. So I need to move accumulator right to store this. So move left ACC, move ACC left. So just a little bit of a storage there. So move it to the right. I then sub left. Okay, jump if you are negative 999 and you're 14, so 14 minus negative 999 would be a really large number. Would be a really large number, which is not right. This is the max box, yeah. I don't want to sub. I guess I want to sub left and see if it's greater than 0. Oh yeah, I just sub left and see if it's greater than 0. So if it's jump greater than 0, then the left is bigger, right? Which means that we are going to move. I don't care about this accumulator anymore that we saved. I want to move left to new. Greater than left is smaller. Is that right? If it is like 14, so if I have 14 in here, and so what is that? That's like 20, that's like 3 minus 14, that'd be negative 11. How does it work? Is it this minus that or this minus that? I trust you. We'll do less than. Less than Z. We want the new one is good to go. So okay, so swap, we move the accumulator to the right, we sub the left. If it's less than 0, we want to keep the new one. So now I want to just move left the accumulator, and that's it. I'm worried about the negative numbers screwing things up, because if I set this to negative 999, 100 minus negative 999 is a really large number, and that might throw it off. We'll get a stack overflow. I wonder if we should just have this be 0. New. Okay, so we move left to the accumulator, and we're good to go then. It does multiple tests like after this, but so we can't see the secondary tests and third tests. And it does look like it's greater than 0, so I might actually be able to move 0 to the accumulator. Okay. So then and actually wait, if you're not equal to 0 calc, you're already 0 here. Oh, I don't have any more snoozes left on ads, and we have an ad starting in 5 minutes. Okay. We're probably not going to get this one done before the ad starts. So we're just there. We just saved. That's it. Okay, in calc. So calc the new one. So we swap whatever backup was into here, and then we move that to the right to keep it, just in case we want to keep it. We sub left. If it's less than this, we're going to keep the new one. So move left into the accumulator and save it. Otherwise, we want to jump keep. I don't need to jump keep. We're just going to then move right to ACC. And then, oh, just do it during the ad. Yeah, I could do that. I know that not everybody gets ads. So, and I think you can see a little corner on Twitch inside of there. I think we can do that. I won't move on if we get it right. Move right, the ACC. Okay, so that comes back into here. This is the new biggest one. And then I need to be able to send this down. If you're, okay, so this is resetting you. And then I need to, after calc, okay, so we choose a new one. I almost want to like jump to end. So jump to end. And then I want to move the accumulator down. Move the right the ACC. I need to save it as a backup, don't I? So I need more. Before we jump to end, I want to save. You're saving. Okay, so that resets the backup. Oh, shoot. No, but you're need to, I need to move. Oh, no. So if you're here, if you're a null, if you're a 0, I need to send what you are down. It's the opposite. It's the opposite. If you're a 0, I want to, okay, hold on. This might be easier. So move left to the ACC, check to see if you're not 0, do the calculations. If you are 0, I want to send it down. Okay, so if you are 0, before I save, we swap. And then move ACC down. Oh, shoot. Okay, so I swap, move ACC down, and then I need to swap again instead of save. Okay. Now, if we're not 0, we're going to do our calculations. So we're going to swap to whatever our backup here is, send that off to the right to save it. We sub left. If you're GLZ, we're going to get a new one. Otherwise, we're going to move right into here. I don't need to say, I do need to save, but I can save across both these, right? Okay, so hold on. So we calc, okay, so GLZ new. All right, ad breaks are started, but we're going to keep on going. Left, GLZ new. Okay, so move right, ACC. Okay, so put this one back. Otherwise, we're going to get new. . 'Cause if we're getting new, I want to move left to ACC. And then I want to save. So sub left, so that's where we lost it. If it's new, go do that one. Otherwise, move this back into here, and then I have to save you. If I do it the other way around, if I say, okay, if you're greater than, if greater than keep, jump to keep, and then that means if we're not keeping, I move you, so move left to ACC. I don't think I can do that. It's gonna be tough. I don't think it matters. It's gonna be the same no matter what. Okay, so if you're less than, go to new. Otherwise, move right into here, and then we need to save you. So I need to start give myself space. So move right in and then save. And then I need to jump to start. Otherwise, new, move left, save. And then we jump to start again. I do that one though. I have to jump after this. I have to not do new for one of them. Okay, so if I do this, we're just gonna move up, down, move up, down. So if I do that, our A was supposed to be 58. No, our A was supposed to be 73 and we got 58. So that didn't work out very well. Okay, so it's 14 goes in. 14. Calculate. Okay, so swap. Move right. Oh, our previous. Okay, so our previous grader goes right. That's fine. We subtract we need to do this twice. I forgot. So we move account right. So move ACC right. Uh-oh. We're stuck in an infinite loop now. Okay, so we got swap, move account. Okay, where did we get stuck? Here. Because you're waiting for me to access left. So here we have move left account. So if we're here, move right account, I need to jump to new. Okay, move left account, and I want to move right. No. Okay, hold on. What happened here? So this one, we got 87, we want 71, so on a third one. So here's 1, 2, 3. We have 50, 71, 60. Oh, we need to reset. We need to implement the null termination, which I thought we did, but I guess we didn't. Okay, so if you're not zero calc, otherwise just save it. Oh, it doesn't like that at all. It's okay, no. Let's see. Oh, wait. I don't want to do that. There. I want to... Okay, JNZ calc. I need to swap, move a count down, then save here, maybe. Thought you would keep the lowest value in the middle box, only move it down when zero termination. Right now I am moving only the highest number down. Okay, and this is, oh, except that thing. Oh, interesting. So sometimes it's working and sometimes it's not. Why is that? So like the third one, it didn't do. So 1, 2, 50, 71, 60, it didn't work. I put in 87, which was the previous one's high number. Which means I'm not resetting somewhere. Which I thought maybe this would... move the accumulator down. Instead of save, we could just try and move 0 the accumulator. It's like I got it almost exactly the opposite now. Now everything else is working, but the second one didn't work. So now we have because I need to save it. Move the accumulator down, and I need to save it, but I don't have room for it. Okay, so we need to use more boxes. That's our problem. We need to use more boxes. Okay, so move 0 to the accumulator. Is fine, but I need to save that if I really want to reset it. I could... What if I don't store it here? What if I send the lowest number to another box, and when zero termination comes, you get that box to out. Oh, send the highest number to a box to output its number. You don't care which number sits in that box at any other time. No, but I do care, right? Because it's the highest within these zeros, right? So this 73 is the highest here. Then the next one is 87, and then the next one's back down to 71. So I can't keep 87. I have to reset that to know that it is the highest. And if I always keep the other one, that I have to know to drop that and reset it down to 0. Unless I'm not understanding what you're saying, which I might not be. Let's see. Yeah, moving countdown. Because if I always store the highest, So one box will count max and reset itself on 0. And whenever it finds a new max, it moves it to another box. The second box only sends out its number when 0 termination comes into the main input. Okay, so I could... That can't be here then. Basically, I need a function that just gives me larger than a previous one. I almost wonder if I want to do something like in here, instead of just storing what this is, I use this as like a function for, no, because like, okay, I need that. So if I don't care about keeping it, and I just pass on which is the highest one that's found, I send in, I guess it knows the previous one and it knows the current one. Oh, okay, so highest so far. So we store a backup. Okay, so hold on. I almost want to reset that. Let's write it down here. And then I'll, here, let me reset. Just throw you down there. So if we do, I take whatever we have, we swap. Backup goes to the accumulator. Oh, we move accumulator right. NG battery, hello. How are you doing today? So that saves what our previous high one was. And then I want to then subtract this. So we're gonna sub left. Doing pretty well. I think we got past where I had played this a long time ago, but I don't remember how far I got. I don't remember if I got this far or not. I don't remember I don't remember really any of these puzzles. It was a long time ago. I did it on stream too, so you can actually see. So if you all wanted to, you could go find the playlist where I had TIS 100 originally, and see me figuring it out. I hadn't done any rest code back then. That was a long time ago. Okay, so I am joining the game though. I do like it a lot. You gave when it got to the graphics puzzles. I've never gotten to the so I've never gotten past like these. I don't know how far. I don't know how big the game is. I didn't even know there were graphics puzzles. If it stops being fun because of like something like that, then I'll probably we'll end it then. But until then, so far it's good. Okay, so I sub left, and then okay, we're gonna check to see if we are greater, if we're less than 0, we jump to new. So we have new. If we're not keeping the new, then I want to move right to the accumulator and save it. And that's what we're, I guess that's what we're getting, right? We've got it back as the previously larger one. If we get the new one, and then we probably just want to send down whatever the biggest one is, right? So we just jump to end. If we have a new one, we want to move left to the accumulator and save it. And then now here we're on end, and I just want to move the accumulator down. And then we restart again. So then if I did this, it's gonna well, that didn't work. That got us 14. That should at least have gotten us 73. Oh, because we're just randomly putting stuff out. Okay, hold on. Now we need to... Okay, so we move this right. We sub left. If we're new, we do left a second time. Otherwise, move this jump end. Okay, so then before the jump end, I have to move left, nil. Yeah, we're gonna have to move zeros from here down to figure it out. Okay, so I still don't see how this is gonna work though. Okay, so then we want you to do so if we're starting, we're going to move up into AC. If we're equal to 0, I guess like if we're equal to 0, then we're going to reset. Otherwise, we continue on. And then this should go back to start. If we're resetting, I want to move accumulator down. If the input box only moves down when 0, the middle box will wait until it sees a 0 before it triggers its left-right boxes. The problem is that this is greater than 4 in here. So I don't see how this is going to get like the smaller greater than. I don't see how this is going to get 71 when the previous greater than was 87. It's always going to be the highest number of all of them, regardless of the null or of the 0. So when 0 comes in, the middle box can trigger right box to send onward whatever is the highest number is. But that the highest number is too high. The top right box will also reset on 0 in its logic. We don't have that. We don't, so that was the problem, is we don't have space for that. Not with the logic that we have here. So I'm not really sure where we would put that in. To here or here. Okay, so if we move this 0 down, okay, you're thinking max calculation box does this. Check if number is greater than previous number. If yes, send down. Reset when 0. Right. So the problem is I don't know how to do that, because if yes, send down. Reset when 0. Okay, so if we start, we swap whatever we had in here before, move the accumulated. So I need to check to see if you're 0 somewhere in here, which I'm not doing, and then reset at that point in time, which we try to do down here. So we try to say like, hey, if you're not 0, run the calculation. Otherwise, do the swap. And then start doing the other things. So okay, so if I do if we start, okay, so we start here, we do we have to okay, so we have to move left to right and check in here before we do a swap so we don't lose it. So we have to move left to the accumulator. We have to check, so jump. You have to move the 0 to the right as well. No need to have jump equal to 0, reset. That doesn't move the 0 to the right. Yeah, we have to do both. Okay, so hold on. Let's try this again. Here, second back up there. Okay, so if I move left the accumulator, we have to check to see. So jump not equal to 0 to calc, right? So we can put a calc in here. Now, if you're equal to 0, then we need to move 0 right, which is move the accumulator right, and then also save it to reset. So that resets. if we're calculating, which means now we need to, we also need to save what we had. So if not, okay, so if it's not equals 0, calc, move, so then I need, okay, so hold on, I need to swap to get the backup to what our previous one was big. And then we send that down. So move accumulator down. So that sends our highest that we found down so far, and then we need to resend. So now we need to move 0 to the accumulator and save it. Oh, but we have that in swap, don't we? So we could just swap it again. That probably works. Okay. We need to jump somewhere after we're done with that. So if we're calculating, then we need to do the entire thing where we're saving it away. So we need to say swap to get the previous one. We need to send you off here. So move accumulator right. We need to check to see we need to do our less than thing. So we sub left. That's moving to left twice now. So that means that this needs to be a move. Do I need to move left null twice? Ooh, I don't remember anymore. Okay, so sub left, and then we check to see, so jump less than 0 is new. If it's not new, then we move right to ACC and save. And then we're done here. So jump to start, for example. I move that down, I swap, and this probably jumps to start. So I can restart that. Where's the move down? Right here. So then we have on new. So it's moving down. Yeah, it's moving down the previously, like the highest one it found in the previous group, right? So like when we get the 0, I need to get the highest of the ones that it saw before the 0. Okay, so move. Okay, so new. If we're doing new, we just want to move left the accumulator and save. And then I guess we're back to here again. So maybe that will work. And then, so if it gets sent up, we just move this on down. So that might work. Now, hold on. I have multiple things going down. So we have move left. Okay, so that's on start. We have one move from left, and that's it. In calc, yeah, I don't think I need these at all. I think we can reset that. So, okay, so move left. So this is going to be move up to accumulator, move accumulator right. So that's one move left. And then, oh, but then this jumps back to here. Now here, oh, so here, if it is a non-zero, I need to move this right. So hold on, I need to move it right, and then I want to say jump if equal to 0. Move commuter right. So a second right for the sub left. And then potentially, okay, so sub left this one. And then we do another move left. Okay, then we move another left over here. So then, okay, so I don't know if this is a new or not. So in calc, if it's new, we're going to move the left. Otherwise, I need to drop this calc. So we move, okay, so we move right instead of move left. Save jump to start. Now I'm doing save and save here. I wonder if I could get away with not doing a save. And then we just move left, nil. Jump to start, move left. And then the very first thing to do here is we have to save. So if we run U, move this to the right. Oh, but you're trying to move this left now. Move account right. Oh, so like, yeah, if we're going with left, I need to move right nil. Ugh. Oh, but maybe I can get away with not swapping there. And then, okay, swap, sub left, move right this. Okay, so a new, I need to then move right, no. No, they're always 73, so that's, it's, that didn't work. Okay, so what happened here? So 14 goes in. the first one was good, yeah, but then the second one is supposed to be 87 because it's the new high. Okay, so then we see 87. It does. Am I moving all the time? It's not. None of them have come out yet, so I'm not moving all the time. Your max accumulator needs reset logic. I'm trying to reset over here. Like if it's not 0, that do swap here. I'm trying to be like really clever with it, and I think that's our problem. I'm trying to reset with a swap because move left accumulator. So if that's 0, it resets it with a 0. Oh, it probably needs a save, not a swap. But now they're all 0s. Okay, that was not right. Okay, so what's happening here? We're taking 14, we move it to the right. So we move you into the accumulator. If you're not 0, we calc, but you are. Yeah, so you're not 0, you go into calc. Okay, so we immediately swap it. We move the account to the right. So the previous one we moved to the right, which is 0. We then sub left. So that becomes negative 14 because that's what it was previously. We then check to see if you're less than 0. We want the new one, which we do. 14 is greater than 0. So then we move left. Oh, that's a problem. Move left. I needed one more. Move account right. One more of those. Nope, but that's the same. Move left account. So that becomes a 14. Move right to nil because I'm dropping that. We save the 14, which I didn't need to because we had 14 here. So maybe I don't need that save. But okay, so now move left to account. So that's the 73. Oh, I need to move the account down before I save. No, I need to swap it. So yeah, I definitely need to swap this with whatever we had previously, and then move it down, and then because like now it's keeping the old ones and it's not resetting. So we swap, move account down. I'm jumping back to start, but I also need to reset. I need to swap again, essentially. I don't think a swap will work here. If I don't do a swap at all and we just... What? I can't delete that? What? If I swap again, how we get... Okay, now we're just completely wrong. 58 was the last one that was done. 56 is... It's not waiting for zeros. Why is that? Move left into there. If it's not 0... I feel like we were close and then I broke it. Can I use this to just return the maximum without state? So start, move left, accumulator. Okay, so I move left into the accumulator. I then check to see if you're not 0. We run our calculations. If we are 0, swap it to what we had previously, which was our max. What if instead of storing it in our backup, we store it over here, our maximum over here? Oh, but this won't know. It won't know because it won't know the number that I'm getting. I can get a deadlock really, really easily. So I swap with our maximum that we stored so far, and then we move that down. But then I need to swap it again because we know it's a 0 to reset what our maximum is. And we go back to start because we're done, right? Okay. Otherwise, we're calculating. So swap to get their current maximum and then store it off to the right so we don't lose it. We subtract from the left. That's where we're calculating. So we subtract from the left. If we're less than 0, it's new, which means we need to jump down to new. Otherwise, we need to move the right back in place. Ignore the one on the left. And then go back to start. So ignore this. Otherwise, if we're new, move the left one in here, move the right one to nil, and then the problem is we're missing save. We're not saving it to the backup. We just have it in an accumulator. So we need to save first, but we don't have room for that. That's there's our problem there. I could return back. Okay, so if I update you, if we change you to be the current, like whatever's bigger. So if we were to do that, we would have let's assume that we have whatever's bigger here, right? So if I swap, so that way this is here, we then sub left. If less than 0, we have basically left is bigger. So left is bigger. Otherwise, right is bigger. So we want to swap and then move accumulator left. If left is bigger, I want to, I don't think this is going to save me any space. So we had the biggest one previously in here. So we move it into here, we sub left. Do we assume that they're both the same? If we assume they're both the same, we sub left. Do I want to take two numbers? So like move left the accumulator, save. Move. I can't move left accumulator. Now I can sub left. Oh, sorry, I hit the microphone. Sub left, if it's less than 0, the left is bigger. Otherwise, if the left is bigger, so let's see, this is 1, 2. Well, because like the problem is I lost the item. Unless I move all this stuff down here. Hold on. Okay, so let's say we just move stuff down here and we started a logic down here. And so then, okay, we say I basically want to first test if so we first check to see if reset. So we get the we get the thing on the left here. So we move left the accumulator. Then if you're not 0, we calculate. So we are 0. So if we are 0, we're going to my brain is having trouble. Okay, if we are 0, we want to reset. So we've already set this in here. We just save. No, we don't want to save. We have to swap. Because we have our biggest there. And we have to move that down. So we have to move the accumulator down. And then we can swap again, which saves the 0 into the backup. So that's our new high. And then we're done, right? So we jump to start. And then we have our calculations. Okay, so we're not resetting. Okay, so in calc, I just want to take our backup. I want to say take two numbers and I want to pass them both up here, and then whichever's the larger number gets passed back to me. I wonder if we can do that in these two boxes here. So if we could say move down to the accumulator. So that's our first number. Let's move accumulator right. Store it away so we know if it's the right one or not. Okay, so that's number 1 is stored here. And then we have to, no, we store the second number here. So move down the account, we save. Number 1 is stored here. Then we move down right. Number 2 is stored here. So 1 is here and here. 2 is now here. I then sub right. If less than 0, then the right one is bigger. So right bigger. If the right is not bigger, that means the backup is bigger. So then we do swap jump to end. If the right is bigger, then we just move right to the accumulator. And then in the end, we're going to move the accumulator now because we've swapped it. Yeah, whatever's in the accumulator now is the biggest one, right? So accumulator down. And then we start over again. So move left to accumulator, move accumulator left. So in calc, we want to, we move our current, whatever's in backup. So we have to swap, move accumulator up, move left up. Then we're going to whatever's the biggest one. So move up, accumulator, save. And now it's saved as the backup, and then we start over again. Okay. So then let's just move up, down. Okay, so you are move left into AC. So if we move left in AC, if you're a 0, you do this thing and we don't need this side anymore. But otherwise we need this one. We need this one we need this one twice. So okay, we'll do move up. Move up to accumulator. If we are not 0. Okay, so jump if not 0 to not end. I guess this is part of calc. If we are 0, we just move it once, right? So move accumulator right, and then we're done. Here's the thing, is like I want to move accumulator right. So we want to move it right no matter once, like at least once. And then we're going to do it a second time if it's not 0. So I need to start. Move. Move up to the accumulator. Move the accumulator right. If we're not 0, calculate it. Otherwise, jump to start. We're done. If we're calculating, then move accumulator right again, and then we're back to start again. So I wonder if that will work any better. Deadlock. Move accumulator right, and you're moving the accumulator left. Because right bigger. Oh, swap, jump in. So then this is move right, nil. Move right to the accumulator, and you're moving left account. Move left account, move account left. Hold on. Move down, save, move down right. So 14 goes in there. We calc, we swap. Oh, do I not need a swap? I don't think I need a swap here. Okay, now I'm new move right nil, so I don't need to do that here. Okay, so that's not right. Two of them were right, but I don't know if that's... I mean, that's got to be just happen. Oh, that was off by... No, because the 76 was right, but I don't get why. Okay. So we have 14 going in. Okay, so we move left. Are you not 0? Let's move it up. We also have a left, so we're going to move that up. Oh, that's why I swapped, because I needed the 0. Okay, so this should be fine. This is going to say like 14 and 14 is going to be the same. So that's going to give me back 14. And then 73 is coming in. Okay, so 73 comes into our accumulator. We calc. Okay, we move up ace. Okay, we move that up, and then I wanted 14 to also go up. Okay, so we move the ACC up, and then, which is the new one that's coming in, and then I also need to swap and move ACC up. And then we move up to ACC and we save. Okay, so move right. So if the right is bigger, we're moving right. Otherwise, swap. So I do I need the move right nil there? I think I do. No, except, okay, that's not the right place to put the nil. Oh, wait, do I have to put it at the end? Jump to end here. This doesn't make any sense. I don't think this is going to write either. That's gonna run into the same thing where it's moving left to ACC. Oh wait. Is it the opposite problem? It's the opposite problem. Hold on. So I'm running into move right to ACC, but it's looking for a new left. So I moved. Right to ACC. Okay, so you're just storing this and then giving it back immediately. So I am moved down into ACC. We save it to here. We move down and to the right. We then sub-right. So that's 2. Okay, so that's 2 times we use left right here. Okay, so wait. Move down into here. We save it. We move down to the right, which is why we have these 2 ups. We sub right, which is then move the account to the left. So that's this one. Okay, so right bigger. Move right to ACC. So then in this case, we want to move ACC left again. But that works there. And then in this case, we need to move right to nil. Ooh, no. Okay, so now you're move left. Okay, so you're on move left. Where do I want to put that where I don't handle it? So I'm subbing right. Do I just not want the nil at all? Do I not need that? I thought I would need that. Move down right. Okay, and now you're trying to do... okay. So move right to ACC to bring that back again. So if you're not that... Okay, so move down right. So that's zeros. So sub right. Right is bigger. No. Now we swap, which swaps these 2. Jump to end. Move whatever we have in ACC down. So that's the bigger one. Okay, move down to ACC. We save it. We move the next thing up to the right. Oh, but now we're, okay, so now we're in this. We ran into the problem where it was right bigger. So move right to ACC. If it's not right, I need to handle this. Why wouldn't this be move right to nil? That feels like it should be right. And now you're waiting for something to, okay, so you're trying to read from the left and I'm trying to read from the right. That's obviously a problem. So I sub the right. Okay, so move down to ACC. We save it. Move down to the right. So that's one where we move left to ACC. We then sub right, so that's move ACC left, so we can sub it. We then check to see, okay, is the right bigger? If the left is bigger, we swap it. Oh, we jump to the end. The right is bigger, so I move right into ACC. So right, move this over again into the ACC. Oh, so this is where the nil needs to be here, because we do end no matter what. So we swap, move right, no. Okay, so far the number, oh no, that's 87. So in the third group, so 1, 2, 3, 87 was in the previous one, so the reset didn't work. So if you're not 0, so if you are 0, swap, move you down, and then let's just move 0 to ACC and save. Ooh, okay. That's looking more promising. I think our max is now working. All right, max is finally working. So let's now we get to figure out our min. Okay, that was a lot. Okay, min is hopefully going to be exactly the same thing, but opposite, right? So let's see. I have I can use this and then go that way and that way. That makes sense to me. Yeah, I think we're gonna have to do that. We'll have to do it down here. This logic will have to be here. And then this will be here, and then this will be here. Okay, so we will start. All right, so first we move up to the accumulator. So that means we need to, in start, up in the accumulator, move accumulator right, move accumulator down. Then we then we have to do our reset. So if you're not 0, we calc. If we are 0, we need to swap. We need to move the accumulator down. We need to move 0. We need to move 999 to the accumulator. We need to save it. And we need to jump back to start. Okay. There's our restart done. Illuminum, hello. How are you doing today? Okay, so time to calculate. I need to do this thing where we're going to send our two numbers. So we're going to our accumulator. This is looking like assembly. This is assembly. So this is a video game in which you play it by writing assembly. That's fun, right? That actually is a lot of fun. I do enjoy it. Yeah, this is a game called TIS 100. It's a Zachtronics game. So if you're familiar with some of the other Zachtronics games, it is like all of those. I'm pretty sure all of the Zachtronics games require some kind of engineering mindset. This one's probably like the most hardcore of them. At least like from what I can tell. I haven't played. I own a bunch of the Zachtronics games. I haven't like played very many of them. Okay, so not just assembly, but parallel multi-core assembly. Yes, that's also true. Yes. With potential mind controlling computer stuff going on too. The plot of it is interesting. It's one of those discovery type plot things where we at every puzzle we get a little tiny bit of story like added in. Like our uncle died, which we think it's a normal death, but I'm starting to get more and more suspicious that this computer killed him, or something about the computer killed him. Okay, so calc. Okay, so we want to now this. Okay, so we move our accumulator up. Right, because we have moved left into the accumulator. So whatever we have up here, we've just moved into here. So let's move the accumulator left. And then we swap with whatever is our lowest here, and we're going to move that to the left also. Definitely got suits and hats suspicions from the journals. Yeah, it's interesting because it's hard to tell whether or not it's actually suits and hats or if like the computer's actually doing something. Okay, so move left. Okay, so then we want to move the accumulator left. Now I want whatever we get back goes into the accumulator. So move left, accumulator, and we save, and then we're done here. So that's this done. Now we write our less than logic, which is a mirror of this, but the opposite way. So we're going to move right to our accumulator. We're going to save it. We're going to move right to up. So up here. We're going to then sub up, and we want to find out, okay, so right now we're doing JLZ, so we're going to do J greater Z. So this means up bigger. So if up is not bigger, we want to swap with what we saved, and we're going to move up to nil. We're going to jump to end. If up is bigger, we're going to move up to ACC, and then no matter what, at the end, we're going to move ACC right. And then we just resets over again, and then you are going to move down to ACC, move ACC down, move ACC down. And then you move down. Okay, so let's find out if it works. Nope. Okay. Oh, right. Because we start with 0. We start with 0. Everything else is looking good, though. So we have to start by... Our very first thing has to assume that we have a 999. So we have to move 999 to AC. And then after this, we're jumping to start. Oh, but then this goes back up to here, which doesn't work for us. So we're just gonna jump to start. Oh, I was really hoping that would work. Oh, I have to save it. I have to move that, and then we have to save you. So hold on, one more. We have to save you. There we go. I think we got it. This is our slowest algorithm yet, but it seems to be working. Okay. Let's go through at least test 1. My brain is fried now. I think this might have to be the end. So how do you all like this? I'm happy with it. Next week, I'm happy to continue on with this and keep on playing it and see how far we can get. I kind of want to get to the graphics part of it and see what that is, since we heard that exists and I didn't even know. So that'll be fun. But yeah, curious how you all feel about it. I'm purposely not clicking the fast button because after this, I think we're going to be done. And it is fun to watch everything sort of flow through. Shaggy, hello. How are you doing today? All right. We used so many more cycles. All right, so we're done there. So we have a few more. So we have to repair 7 more before I guess we get to go to this thing. I wonder, okay, so we have to pair all to the here. So we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all sandboxes here. So that's gonna be interesting. Cool. Okay, so I plan on, like, so far I think this will be fine. Like if we were to take a look at what this next one would be. Oh, interesting. We haven't played with stack memory nodes yet. We'll have to Oh, because we could throw things in there and then get them out because they're stacks. Okay, nice. That would have made some of the previous ones a lot easier if we had stacks. I wonder what their sizes are, like how many we can put in there. I wonder if it's like this is that. But cool. So I'm going to go ahead, however, and return to our segment list, and we will work on this next week. I'm doing the fun streams every Wednesday. I might be overselling the graphics puzzles a bit, but it's pretty much writing colors to coordinates. I mean, that might be good. That might not be good. I don't know. I've never gotten to that point. Like I'm past. I think this. I don't remember this one at all. I remember like the first two a little bit, kind of. I think I only got to like here before, at most. I don't remember. So we are definitely past wherever I had gotten to on my last time we streamed this. So I kind of want to at least get through all of. I kind of want to at least get to the visual stuff. So at least one more stream. Oh, the fourth was where the graphic starts. Okay, I wonder if like this is the entire game and then it ends over here. Well, either way, I'm going to go ahead and call it for a day. Everybody, thank you so much for hanging out with me today. Let's see. Today is Wednesday, so no more streams for the week. That means tomorrow I'll get to spend time trying to like cut up some of the previous videos, turn them into shorts, turn them into like edited videos, sort of like learning how that goes. I have one that's coming out tomorrow, which is going to be the first cut up version of the what is it called, the Build Your Git client stream. So I'm actually really interested to see how that goes and how that does. And then after that, I'll be back on Monday to continue with the Git client project, which we're getting closer to the end, but we still have, I think we're over halfway through, but we still have some things going on. So anyways, I hope that you all have a great rest of your Wednesday, and I will see you next time. Bye.